The Flood Similarity workflow is part of the Flood Event Explorer and enables the user to investigate and analyze arbitrary flood events across Germany. Starting the workflow, we see a map on the left-hand side and a time series chart on the right. The map covers Germany and shows in blue points the locations of all available gorging stations. At the time of recording, there are 515 stations available. Custom layers might be added to the map in various ways. For example, we can add a layer via drag and drop from the local file system, in this case, the catchment of the Wittenberg station. The layer is listed in the Layers tab and can be removed like this. In the near future, catchment boundaries can be added from a layer catalog or will load automatically when a station is selected on the map. Next to the discharge time series shown as a green line, we see the classified magnitude of the discharge values as blue bars and greenish areas that are identified as potential flood events by the backend module. The upper part of this chart sets the time range of interest. For example, we can set that from 2002 to 2013 by using the slider at the top. The minimap of the time series at the bottom allows the user to move the focal area over the time axis and change the size of the focal window. We will demonstrate a small example by moving our focus to the most beautiful state of Germany, Saxony. We select a gorge south of Freiberg, namely Berthelsdorf at the Freiberger Mulde. To get a better picture about the area we are talking, we load the catchment boundary, this time via an URL. The focal area on the map zooms automatically to the boundary of the newly added shape. As we scroll down a bit, we see 3 panels that list settings and a configuration summary for the event exploration. On the left-hand side, we see the analysis options provided by the backend. The center panel shows a list of selected flood events, and the panel on the very right shows whether all prerequisites are fulfilled to start the analysis. The checkboxes are filled automatically in the moment all required parameters are available. We will choose 2 events for the Berthelsdorf station, one from the year 2002 and one from 2013. We use the minimap at the bottom to move our focus to the year 2002 and decrease the focal window to see more details about the time series. We select the event in August 2002 by clicking in the greenish area in the chart, which at the moment changes its color. The second event is selected by moving the focal window to the very right, picking the flood event during June 2013. As we selected 2 flood events, the center panel below was populated and the Start Analysis button is now activated. For that example, we will only request the antecedent precipitation index from the backend module. Hitting the Start Analysis button will pass the required information to the backend module and the processing will start in the background. Depending on the catchment size and event duration, the processing might take some time. The results are shown at the bottom. Next to the requested flood characteristics, API in our case, standard auxiliary data is provided, including the discharge time series, precipitation over space and time during the event, and the soil moisture at the event start. The results are grouped into expandable tabs. Investigating the API, we see both flood events side by side, and the maps show pretty different pictures for each event. For the 2013 event, The wetness of the catchment before the event with an average API between 180 and 200 was much higher than in 2002 with an average API of about 40. Comparing that with the discharge time series in the tab below, one can argue that the antecedent catchment wetness alone cannot explain the higher magnitude of the 2002 event on the left-hand side. Using the auxiliary data, let's investigate how precipitation evolved during both events. Expanding the corresponding tab shows a map of precipitation values for the catchment of interest and the associated histogram for each day of the event. The slider below the map allows for a synchronized temporal motion through the event and enables to see how the precipitation field was moving over the catchment. As we move through time using the arrow keys, we observed rain fields for both events. However, at day 13, an average of about 200 liters per square meter were recorded during the event in 2002. This matches well with the strong rise and peak of the discharge values of that event. Heavy precipitation for the event in 2013 shows up later as we move further through the event, but do not reach the same order of magnitude. Both peaks for discharge and precipitation are observed around day 26 and 27 for the event during June 2013. Based on the presented data, one can conclude that the event in 2002 was very likely driven by very heavy rain only. In contrast, 2013, the combination of high catchment wetness and strong precipitation caused the flood event. That was a short presentation of the flood similarity workflow. Next development steps will include the computation of more flood characteristics, parsing parameters to the applied methods, and the possibility to explore spatial dependencies between the gorging stations.